Okay, so this is chapter 3-2. This is recording number 3. All right, so we're going to talk about some teacher strikes here. And again, as I've said so many times, these are just examples, okay? They may not be particularly interesting examples, but they're metaphors for problems that you will encounter in your other classes that require this sort of an analysis. So don't be put off by the fact that these are kind of dumb examples. The number of the number of public school teacher strikes for a certain number of school years, 1, 2, 3, 4, 5, 6, for 6 years, okay, is shown below. We want to find the sample variance. So we've sampled, it's a random sample of school years. We've sampled 6 out of however many, okay? Find this sample variance and standard deviation. Now, unfortunately, he didn't write down the formula here, so you're going to have to kind of bounce back and forth. I always recommend writing down the formula when you're doing the problem. It helps you avoid mistakes. So here's a formula for the variance. It's n times, and then in parentheses, you got to watch those parentheses. It's the summation of the data values, the x's squared. So x1 squared, x2 squared, x3 squared, add them up. And then over here is add up the x's, x1 plus x2 plus x3, all the way up to x6. Add those up, and then you square it. There's the distinction. And then down below, it's n times n minus 1. So let's see if we can figure that out. So summation of x, okay, 9 plus 10 plus 14 plus 1, I'm sorry, 9 plus 10 plus 14 plus 7 plus 8 plus 3. That's the x sub 1, x sub 2, x sub 3, x sub 4, and so forth. Okay, you add those up. That's this guy. That comes right here. Then we're going to square it, but that's what we needed to begin with. The summation of x squared, that's this guy. Well, it's the first data point, x sub 1, that's 9 squared, plus x sub 2, the second data point, squared, plus x sub 3, that's the third data point, squared, and so forth. So you see the distinction, right? If you don't have those, if you do those wrong, you're going to be way, way off. So you got to be very careful, okay? All right, well, okay, here's the formula. He's got the formula right here. So you do these calculations, and then you plug them into the formula, get your handy calculator out, punch your buttons, and there it is. The variance is 13.1. You take the square root of that to get the standard deviation, okay? All right, so this sample variance is 13.1, sample standard deviation is 3.6. Now, these are the same results as we got before when we use the original formula, the formula that's the actual definition, okay? All right, so the concept here is it's just easier to do the calculation doing it this way. Now, the reality, of course, is you're going to use a program for this, right? Okay, so for example, I just Googled variance calculator and I got a bazillion hits. Here's just one, calculator soup program, okay? Enter the data set. So you type in the data, whatever the data happens to be. I might be able to even just copy and paste it. Let me see if I can do that. Okay, cool. I was able to just copy and paste it. All right, so that's the original data. It's a sample. It's calculate. Boom, there it is. 13.1 is the variance, standard deviation 3.6, blah, blah, blah. And give me one quick second. Okay, yes, that is exactly the same answer as we got before according to the book. Okay, so here's my advice. Here's my advice. My advice is do the example problems. Make sure you understand how to do it. The reason I want you to do the example problems or the examples in the book is because it walks you through it. So if you get stuck, you don't get frustrated. You just look at the example, right? So do those. Do the homework problems, but everything should be done by hand, just so you can say to yourself, okay, I know how to do it. And then in real life, what you're going to do is you're going to use these calculators, and they're all basically the same. You enter the data, they're separated by commas. These are called CSVs. comma separated values. You type in the number, comma, another number, comma, and so forth. Okay, these are the numbers that we had before. Okay, so there's millions, well, not millions, there's hundreds and hundreds of these calculators on the internet. Pick the one you like. That one is good, the calculator soup. Mathisfun.com is another website that I like, and it has calculators too, I believe. So just find the one that you like, okay? The last thing you should do, in my opinion, is what the book wants you to do, and that is learn how to use a particular, Casio calculator or one of these scientific calculators. It's just not worth your time and effort. Everybody's busy. Time is your most precious resource. You just don't have the time to screw around with a calculator when the websites are so easy to use. Okay, so now talk about grouped data. The concept here is exactly the same as before. Uh, what I told you before was when we have grouped data, the frequency tells us that there's like there's three occurrences in this class. Here, there's four occurrences in this class. If I knew what those occurrences were, if I knew exactly what they were, I could just do it the way I've been doing it. I wouldn't have to do any of these approximations, okay? But the premise here is that we don't know what those exact numbers are. All we have is the grouped data, okay? So we have the grouped data. What we're going to use is we're going to say, well, you know what? I bet you it's close enough for government work for me to just assume that these various data points, like these three guys right here, are approximately the midpoint. It is close enough for government work. So it might be that it's in this class. So maybe it's 16.1, but that's close enough to 18. It's a little bit less, but this is a little bit more than the original data point. Or maybe it's 19.5. Okay, well then 18 is an approximation, is a little bit less. On balance, it'll all work its way out. So that's the concept here. So the three data points here, I don't know what they are exactly, but I'm going to assume that they are approximately what the midpoint is for this class. Same thing here. The midpoint for this class is 23. These five data points, I'm going to assume that they're close enough for government work to be that they're 23. Okay, so that's the basic concept. That's what we did before when we were calculating the mean. Okay, so we got a formula for that. It's the same formula as before, believe it or not. Oops, where is it at here? It's the same formula as before. You take these individual data points, you square them, and this one here, you add them up, and then you square it. I mean, that's the same formula. And your book, you can make the comparison better than I can here on the computer screen, okay? But it's the same formula, okay? The F is the number of occurrences. So how many of these guys do you have? You have F of them. So you have, like, let's say 3 of them here times 18 squared, okay? So you have 3 of those guys. So it's 18 squared plus 18 squared plus 18 squared. That's the concept, okay? All right, so then you plug it into the formula. Okay, here's the algorithm for doing it. All right, so it's not as hard as it looks once you get started, but you got to stay organized. That's one of the things you learn from a class like this, is how to stay organized, okay? But that's the concept. We're making this approximation, and the approximation is premised on the concept that the data points that are in here, these 5 data points, are approximately each 23, approximately. So 5 times 23 is the same as 23 plus 23 plus 23 plus 23 5 times. So that's what's going on here, okay? Okay. All right, so here's a little summary. It's very, very handy. I'd say make a photocopy of it. It's worth the money to go to the library and make a copy. Or you guys nowadays, kids use their cameras for a lot of this stuff. Take a picture of it if you can print it out. Okay. Here's a little summary of how we use variance and standard deviation. Okay. They're used to determine the spread of the data. Okay. Here's an example. The consistency is another way of looking at it. If something is consistent, that means that over and over again you get the same value, right? Well, that's kind of what variance and standard deviation is, right? Because if it's a small variance, that means that it is consistently some particular value. So like nuts and bolts, the variation in the diameters, how much those diameters vary, it has to be small or the parts won't fit together. There are very strict requirements in manufacturing to make sure that everything fits together. Otherwise, whatever your parts are, they won't be able to be assembled to make the components, and then the components won't be able to be assembled to make the system, and then the system won't be able to be assembled to make the final unit, whatever it happens to be. So that's why you want it to be as consistent as possible. So you want the variance to be as small as possible, okay? Okay, so now, later on what we're going to do is we're going to learn about this Chebychev's theorem, and what that's going to tell us is that the standard deviation, standard deviation and variance are basically the same. They're very, very similar. One is the square root of the other. So if you know one, you know the other. Let's put it that way. So if you know the variance, you know the standard deviation. If you know the standard deviation, you can make some inferences about how much of the data is within a specified interval in a distribution. So you've got the mean, and you've got within 2 standard deviations of the mean, you're going to have 75% of the data. All right. Coefficient of variation, what does that mean? Okay, so I'm at 12 minutes here, so I think this is a good place to stop. The next video, we'll talk about the coefficient of variation and Chebychev's theorem. So this is the end of this video.